In this problem, we're told to suppose that the average pizza delivery times are normally distributed, and that is key, normally distributed, so we can use z-scores, with an unknown population mean and a population standard deviation of 6 minutes. A random sample of 28 pizza delivery restaurants is taken and has a sample mean delivery time of 36 minutes. So let's discern what we're given first before we try to figure out this problem. We're told to find a 90% confidence interval estimate for the population mean delivery time. So what that means is we know we're going to have the error bound is going to equal the z-score, or we have z alpha divided by 2 is how that is signified, times the population standard deviation divided by the square root of the sample time, the sample size, n. So let's see what we're given in our problem. We're given a population standard deviation of 6 minutes. So we know sigma, the population standard deviation, equals 6. A random sample of 28 pizza delivery restaurants, so we know n equals 28. And then a sample mean delivery time of 36 minutes. So we know that the sample mean, or x bar, if we want to call it that, is 36 minutes. So let's find our margin of error for our confidence interval first. That's the EBM. So what is the z-score for 90% confidence? We should know this. We should know this one for 90%. We should know 95%. We should know 99%. What those levels of confidence, what z-score they correspond to. So for 90% confidence interval, we're looking at a z-score of 1.645. We determine from the given information the population standard deviation is 6, and then the sample size is 28. So that is approximately 1.865. And we could have simplified this further, but we're not keeping it exact anyway. So you can go ahead and put that in your calculator, get the answer of 1.865 for the error bound. Now the confidence interval is just plus or minus that margin of error from the sample mean. So we're going to have our lower bound is going to be the sample mean minus the bound on error. Our upper bound is going to be the sample mean plus that margin of error. So that equals 36 minus 1.865 and 36 plus 1.865, which gives us 34.135 to 37.865. And what this means is that we can say we are 90% confident. Now, don't use any language like probability or 95% chance, because the confidence is in the method. It's not in the individual interval. But we can say that we're 90% confident that the population mean is between approximately 34.1 and 37.8 minutes. Now we should know how to do this using our calculators as well. So let's go ahead and get out our graphing calculators just to check. How we would do this with a z interval such as this, we would go to Stat, Tests, scroll down to z interval, Stats. It'll be by default sometimes on Data, but we want it on Stats. Enter in 6 for the population standard deviation, 36 minutes for the sample mean, 28 for the sample size, 90% or 0.9 for the confidence level. We hit calculate, and it gives us 34.135 to 37.865, which verifies what we had originally written. I did notice, though, I rounded incorrectly. This should be 37.9 minutes, which I should have seen from the 37.865, not 37.8. So again, showing us it's always good to check, especially when it's something as simple as just entering in a few statistics, hitting enter, and it giving us the interval to check the solution that we've already found. So we are 90% confident that the true population mean is between 34.1 and 37.9 minutes.